Most tutorials that you watch on YouTube, usually they bring a very clean and simple data set, usually just one file. They go analyze it, do some nice visuals, and they tell you this is what you do as a data analyst. But in reality, there is much more than that. You usually have many files that you work with at the same time. You have a database, you might have data that is not yet structured, not clean. There's so much going on in the real data analyst world that a lot of people don't cover in their tutorials. So today I'm aiming to cover a topic, the e-commerce topic, that is one widely used and that has so many cool KPIs to analyze so that we can bring and add value to any business in e-commerce. We're gonna use DuckDB because it's quite fast. We're gonna see why it's interesting to work with DuckDB in a few seconds. And primarily using SQL. So I didn't want to mix and match SQL, Python, Power BI, whatever. Today is mostly querying with traditional SQL, and we're going to answer all business questions that we have and that we're going to set. So why choose DuckDB for this project? DuckDB is perfect for local data analytics, especially when working with flat files like CSVs or Parquet files. So we're going to download this dataset from Kaggle, which is a platform where we can get data sets and people share their projects, their code. They also have competitions in there. And since we're going to download these CSV files and we want to query with SQL, we don't necessarily have an access to some sort of database. We're going to use DuckDB that has the feature to import or read from CSV files or Parquet files or even other types of files. And we're going to query normally as we usually do with SQL. So a few key aspects of why choosing DuckDB. One is that we literally have no setup. It's very quick. I'll show you how to install it, whether you're in Mac or Windows. It's very easy and straightforward. And it gives you that vibe of simplicity. You can have a notebook in there. You can literally write the same SQL as you usually write. And it's quite smooth and straightforward. And it's nice for prototyping, or in this case, I'm doing a video and I'm gonna show you so you can follow along with me as well. I'll share with you the source code, everything on GitHub, so you can, if you wanna speed up the process, you can copy and paste things and test along the way with me. The second thing is it's super fast performance. You can literally run hundreds of thousands of rows within seconds, and that's one of the power of DuckDB, definitely. It's SQL native, so that's amazing. You can also write Python, but it's SQL native. We already know in SQL you're gonna use it in here, and that's fantastic. And fourth, it works directly with files, and for example CSV, Parquet, Excel as well, I think. So all these things without necessarily going and using Python and pandas, .read CSV and all these things that you do with Python. I'm not saying Python is not a good option. I'm just saying that in this video, we're focusing primarily on SQL, and we're gonna manage to answer everything just with SQL. Next, how to install DuckDB. So very simple. If you're on macOS, you just go do brew install DuckDB. If you're on Windows, you just do basically just grab these pieces of code and put them in your terminal. So for example, just call the terminal, and in your terminal you can just write brew install DuckDB. If you're on Mac, I've already done it, so I won't be doing it again, but it will run within a few seconds and you will have it installed on your MacBook. You can do the same for the other operating systems, and you also have access to their website. They show you things in a very easy way. And if you do it within a notebook, for example, if you are inside VS Code, you can within a cell just write pip install DuckDB and you can still do it, but usually I'd prefer doing it within the terminal or the CLI. So next, we're going to download the dataset from Kaggle. You just look for Brazilian e-commerce public dataset by Analyst. Let me see if we can open it in here. Oh, it's here. So yeah, this is the website. I've put a link in the README on GitHub, but this is the one. You just basically look into this and you have these. If we click on download, it will give us the option to download the zip file, and there are 9 CSV files inside of this project. And you can see them here on the right side. So you just download them either as a zip file or one by one, and you put them in a folder. So the way I suggest to do it is create a folder in your desktop, and inside that folder create another subfolder called data, and in it you can add all those CSV files. So for example, if we look in here and I bring this from my desktop, I have this doc in here called SQL e-commerce cohort, and in here I have this data in which I have all the CSVs. Don't bother too much about the rest. You will have just your folder, your subfolder that will have all the CSV files for now. So when you have the data set, we can go start look into the data. So we have basically 9 tables. This is an e-commerce project. So basically we're going to have orders, items, payments, customers, sellers, geolocation, all these things. And this is a nice visual here to see the relationship between the tables. So SQL usually is for relational databases. So these are databases or tables that have relationships between each other. So for example, we can see between orders and order items, there is a relationship and there is one key ID to connect them together. And if you want to join, it's order ID. Same with reviews and orders, we also have order ID. So for example, if I'm looking at orders and at some point I want to bring the reviews, I will just join it with the reviews table. And so on. We can see the products table, we can link it to order items via product ID. There's another seller ID here to join order items with sellers, and so on. It's always good to have this mental picture of the data, because rushing into querying, you'll end up just being lost, and you'd rather discover your data a little bit before jumping into coding, you know. So now let's jump into what we're going to cover in this. So this is an e-commerce data set, as we said, and we're going to have 3 main business analytics areas or buckets that we're going to focus on. And in each one of these buckets, we're going to analyze 3 different KPIs. So overall, we'll have 9 KPIs we're going to focus on and look into and analyze. The first one is the revenue and growth. Second one is product and category performance. And the third is geographical insights. I chose these because they are the ones mostly in demand in e-commerce. So if you're applying for jobs in e-commerce, or you just enjoy this kind of industry or topic, you're looking at the right things. So if you want to use this project and showcase it to apply for jobs or give you some ideas to start from, this is a great starting point. So now let's jump into DuckDB and I will show you how to set up things. So if we go to the terminal, I am on MacBook, but if you're on Windows, you open your terminal in there. It's good to access the folder. Let me see in here. So I have this folder here called Data Science Projects, and I need to go and access the, so for example, for you, you can create a folder, call it, for example, Data Analyst e-commerce. Inside of it, have the subfolder data, and inside of it, all the CSV files. So what you can do then is you need to go and access it in your terminal. So you either, in a very simple way, do a right click on the folder itself, go to services and open new terminal at the folder. So you can see that here it opened on Data Science Projects. But if I want it to be inside of this SQL e-commerce, I can just cd into it. So I can cd and do SQL e-commerce cohorts. I put it in between those brackets because we have spaces in the name, and now I am inside of it. As you can see here, I am inside of it. So now that I'm inside of it, what I'm going to write is DuckDB and the name of my database. So for you, it will be new, so you can name it the same as me, or you can give it your own name. But in my case, since I've already done it, so it's Brazil_ecommerce.db. And why is it? Because the e-commerce data is from Brazil that we're having. That's why I named it this way. And you do -UI. And this one will open up the DuckDB UI for us. Just clicking on it, and we can see that it's opening DuckDB. For you, it will be something completely empty, so don't worry too much about this. So let's do like this. You can see it's, let me zoom as well. You should see a blank page if you never used DuckDB anyway, and you're gonna see there are 2 main sections here on the left. You have the notebooks, same as you do usually in VS Code or in Jupyter Notebooks, and attached databases. In your case, you won't have anything, so you can just go in notebooks and you can create a notebook. And when you're going to create a notebook, you can give it a name, give it whatever name you want. So you can say Brazil e-commerce project. And you will start from scratch. And whatever here cell, you can see here, if we click on a cell, it has access, it will create for us a new database. And you can see here that we can run instance SQL directly within our cells. So this is cool. We have the notebook experience, but we will write SQL in it. And obviously in the databases, you will not have anything. You will have this main, but you won't have any one of these tables. So let me get rid of them. I will drop them because I've had them already in here. And by the way, you're going to find all the code on GitHub, which I will link it in the description for you. So you can go and literally grab the code and reuse it yourself. So if you don't want to rewrite everything that I'm doing in here. So let me remove this. I don't need it. So I have this, my project in here. So we can obviously close this, we can open it, so we can have a look, and you can have this one as well, so you can see and analyze some of the results, but you don't necessarily need that one. Let me just briefly show you here. On GitHub, you have, let me do this. I've put here a README file that will give you some tips on how to do the setup, how to organize your files, the code base that I've put here on e-commerce analysis, and how to set up things. So this e-commerce analysis, you're gonna find all the code. You just go to the relevant portion and you can just copy and paste it, as simple as this, so that you can follow with me what I'm doing. So now we have this database and it's empty. So we need some data to start playing around. So here I've just put some questions that you might have. So why DuckDB? Obviously, we already covered this in the slides at the beginning, but DuckDB is basically a way for us to write some proper SQL in a fast way, and it's very portable, doesn't require from you a server. You saw that we just wrote one single command in our terminal and we have this nice UI that we can use. It supports most features that we have in SQL, like the CTEs, joins, aggregations, and everything. So here, so that we test, we can create a table called customers that will take from those CSV files that we downloaded from Kaggle. So we have data slash, and we have the name of our CSV file. So if we look briefly at our data here, so it's inside data, and it's this one, customers underscore dataset. So for you, if you put it inside a subfolder and you called it something different, then you'll have obviously to adjust this one in here. So when you do it, we're just gonna run, and we're gonna see here, customers was created instantly. And we can do the same thing for all the others. Let me get rid of this. We can do it for all the other tables. So we have the geolocation table, the orders table, all those CSV files that we have 9 of them. We're gonna do it for each and every one of them. So if we just run this, we're gonna see on the left here, all these tables created for us. So now we have already all the tables within a database in DuckDB, and we're gonna be using SQL to do everything. And what's cool here, if you just wanna have a quick look, if you just click on one of the tables, you can see at the bottom what you have. You can even see preview the data. It gives you a quick preview. You wanna look for geolocation, and you can do a quick preview. We can see we have 1 million rows, and you see how fast we had the data opening. It's just amazing. And here you can see distinct values, how many. It gives you a brief overview of your data. It's always good and nice. Usually you have to write a query, select everything from orders, and you have a look yourself. But now just orders, I can see all the columns. I can have a preview of the data. And that gives me a good starting point just to understand the columns that I have, which are the primary keys and foreign keys and so on. Plus, as we looked at our PDF in here, we can go back into it when needed to get the relationships between the tables. So now that we have our tables, we have them all on the left side, we're gonna go and just have a quick look at our project. So one, we wanna just frame the project. We want to understand what's going on. So it's a very important part of a data analyst job is to understand the requirement, understand the business, what we're looking for, and not just throw yourself at coding and solving some random problems that no one really cares about. So here it's just an idea of what the project is about. So Analyst is a marketplace that connects thousands of small Brazilian sellers with shoppers nationwide. 100,000 real orders between 2016 and 2018 give us end-to-end visibility on the product, the seller, payment, logistics, and reviews. And by the end, you'll be able to turn these raw CSV files into crisp, decision-ready insights using only DuckDB and SQL. So you set the tone, what's the data, what's the time frame of that data, what we're kind of looking for, and what are the tools that we're going to use. That's very important. You do it first. So here, we identified the business problems that we want to solve via analytics, and we spoke about these 3 baskets: revenue and growth, product and category performance, and 3 geographic insights. So always a good thing initially is to have a quick look on your data and see how many rows do you have in it and all these things. You can do it manually, or you can create a quick table that we just have a column called table name and another column that will have the number of appearances. So if we run this one just gives us all the tables that we have in our schema. So you'll have the ones that we created plus some ones that are cached inside DuckDB. So we'll have all the ones that we have here in our main, plus some others that we don't see, they are in the back end of the system. And here we look at the code in here, we can see select category names as table name, and this is just a way for us to get that column name as table name and the second column name as the count basically. So if I run this, you're gonna see that we have all of our tables because we've used union all, so that we kept union adding one row underneath the other. So we have the category names, the customers, geolocation, basically all the tables that we have in here. We just had the row count of them. Gives us a quick insight on the big tables, the small tables, or whatever. We could have done it manually just by looking, and we can see here the results. But it's nice to have it in here as well, just a way for you to explore the data. A second thing that is important to look into is to check for duplicates. And for example, here we're going to look inside the orders table, the order items, and the payments. These are 3 very important tables for an e-commerce project, so it's always worth having a quick look in here. So it's selecting the IDs in our table. So if we look at the orders table, it has this order ID, and we just want to know if there are not duplicate order IDs, because they shouldn't. It should be unique IDs. So we just look at the order ID and we want to just count everything. So we just want to count each and every order ID as n, just as a repetition, from main.orders, so main.orders, to access that specific table. We want to group the results by order ID. So order ID, in your select statements, the group by has to reflect all the columns that you've used in the select statement, apart from aggregations. And here we have an aggregation to count, so we don't include it, but the order ID has to be in here, otherwise we'll have an error. And here having count everything above 1. So what does it say? It says that if there is a IDs are repeated more than once, it should give us that. So if we run this, it will say 0 rows. So if I did or equal to 1, which means that basically if there's 1 repetition, it will show it. If I run, it will give us multiple ones, because there are all of them, they appear once, but that doesn't make sense. So this is just a quick snippet code that shows us that there is no duplicates. Okay, let's keep going. The same thing, we do it for order items. Is this a simple check? We're looking at order ID and order item ID, and we do the count and we check for both of them, and we see if the count is above 1. This is just a quick check. We see rows 0, so there is no duplicate. And we do the same for payments, looking at the order ID and payment sequential, and we just check if it's above 1, and we can see here 0 returned. Here we have this step to create simple views. So why do we create a view from a table? A view is basically just a snapshot of a table. It's like you take a picture of that table and then you can go and play around with it without necessarily affecting the main table. Especially if you're going to alter it or do some big changes, it's always a good idea to use a view instead of using the main table. But usually when we query, we're not affecting the main table, we're just querying from it. So everything that we do doesn't affect the main table, but it's just a good way to approach things, especially if you know that there will be some alterations or that you want to capture a specific snapshot of the data in a specific time and reuse it for whatever purpose. So if we run this one here, so we can just see, it's easy, just put create view, you give it a name, and then from where? From orders. So basically we select everything from orders and we put it inside a view called clean_orders. So basically we just duplicate it, but just like an image that we take from it. We do the same for order items and we do the same for payments. So you're just creating those views. And now they were created, we can see them, they're in here on the left side. So we can call these instead of calling the main tables, or we can still call the main table. So it's up to us in here, but it's just good to know. That's why I included it in here. Okay, now let's jump into bucket number 1, and here it's revenue and growth. So this one, revenue and growth, is one of the most important ones usually in e-commerce because everyone cares about the revenue and the growth of the business overall. So the tables that we're going to use are the orders and order items. We can see here that we've put clean underscore and clean underscore. We're taking the views, but you could have taken the main tables if you haven't created the views. So for this KPIs that we're gonna look into, we're gonna mainly use these tables, and if we need anything else, we're gonna add them as well. So because here the data is pure sales metrics, so we're gonna use orders basically. So the KPI number 1 is the monthly revenue trend. So we're gonna look at the monthly revenue trend. So here we're gonna look in the orders table and the order items. So if we have a quick look in here at the orders table, we can see in the orders what we have is we see if it's delivered, we can see the purchase timestamp, we can see the order when it was approved. So we can see mostly date time tables. And if we look at the order items in here, we can still see the order ID. So we can join them on order ID. And here what's interesting is we can see the price. And that's why we're gonna have to link them together. So if we go back to our code, but here initially we want to do a quick checkup first. We want to see if there are any null values or negatives in prices so that we remove them. So we don't want prices that are 0 or that are -20. That wouldn't make any sense. So we just look at all the rows as rows total. So we're gonna have this as we just rename the column using as, and we're gonna look at the sum of the price if it's null or under 0, as we're gonna add them as rows bad price. So if a price is 0 or below, we're gonna count it in there. And here we're looking at the column, date column, orders approved, and we also want to see if it's null. We also add it in there saying that, okay, you have a few missing dates. So those we're gonna, depending on how many we have, we're gonna get rid of them or something. So when running this, we can see all these rows, how much we have. We can see there are no bad price rows, so that's great. But we still have 15 missing date rows. So we'll have to clean them or get rid of them. So in this case here, we just created this view in here. So we put create or replace view. So if it already existed, it's going to be replaced. If it's new, it's going to be created. And here we're going to select everything from orders. Apart, we're going to add this condition here or filter when the order approved at, which is our dates. If we look in here, order approved at, apart when it's null. So we're going to extrude them basically. And now we created this view KPI1 and we can see it in here as well. So now we're going to go into our main query, and looking at our main query, we're going to split it into. So this is called a CTE. So basically when our query has two distinct parts or maybe even more, the best way to approach it is by using a CTE first, and then we use our main query and we call what we wrote in the CTE. So in this case, what are we looking for? What is the KPI again? It's the monthly revenue trend. So in this case, we're looking at the revenue, and then we're aggregating the results by month. So we're looking at two different pieces in here, and we could have done everything in one big query, but it's just not nicely readable and not very reproducible either. So what we're gonna do first is in the CTE, we're gonna calculate that total revenue first. So we're gonna create this width. The CTE will start with the width. We give it here the name, order totals. And here we're gonna select the ID, and we're just gonna sum the price and name it as order revenue. So the ID here, we have it in orders, and the price, we have it in the table order items. So here, there is a shortcut that we use in SQL, is instead of rewriting the whole name of the view or the table, we just give it an alias. And here, orders is O, and order items is OI. So when we just want to call them, we just say O.order_ID. So it says that we're taking the order ID from the table or the view called clean_orders. And here when I say OI.price, it knows that we're taking it from order_items, because price only lives in the table order_items. So that's something very important, and it's the standard way of writing SQL basically. And here we join. It's an inner join. If you write to join, we inner join, only keeping the rows that are matching in the ID on order ID. So we're matching on the same ID, obviously, otherwise it won't be matching. And here we group by the results by the column that is non-aggregated. So here this is an aggregation. We don't add it. We add only the ID. And then when we go into the second phase, in here we're gonna write our normal query, starting with the select, and we do all the things that we do. Here what we're gonna do first, we're gonna go into our column that we have in order, where we get the date. And what we're gonna do, we wanna just extract the month. So if we look again at the column, we can see that this is how the dates look like, okay? But we only want the month. We don't want the date, time, and all the days and everything. We just want to look on a monthly basis. That's our goal. So there's this simple function that we can use. It says date trunk. So we're going to truncate the date. We're just going to take a chunk from it, which is the month. And we just do date trunk, and we give it here the name month from this column that we have in the order table. And here we just do as month. So here we've used this clean orders where we excluded the null values of the date time. So that's why we use this one, CO, clean orders. We have done it here, and now we have used it. So basically you either bring it back again, which is a smart move, or you have to rewrite where this is not null, which we don't want to do it in here. So we rather just bring it and make sure that we don't have those nulls in the first place. We're gonna join order totals T that we get from the CTE basically on order ID. So either we do it this way. So I wrote them here so you have both of them. So you do join on, and you do O.order ID equals to that. You explain exactly which are the common column. Or if it's anyway the same name of the column, you can just do using order_ID. If it has the same name, you can do this as a shortcut a little bit. Then we group the results by month, and we order the results by month as well. So if we run this code, we can see here that we get on a monthly basis, and we get the total revenue for each month. And this is how now we have just looked at the KPI of monthly revenue trend. And here we are. So it's always good to have some sort of description after finishing your analytics on a KPI. So here I've just added here, we can see that the sales ramp up steadily through 2017, and you can add your own input into it. So when you do this project, look at if there is some sort of trend pattern. Did it go up? Did it go down? When did it start to go up or down? That's up to you to figure things out. We just here always nice to add some sort of insights afterwards, because that's the thing you're going to report to the stakeholders or the clients or the person that you report to. Even for yourself, it's a good habit to always add a description for it. Second KPI, we're going to look at the year-over-year growth percentage. So this one is a KPI that you will see a lot in e-commerce, and it's very important so that the company usually knows the growth over year and did they achieve their quotas or not. So it's a very important one to focus on. And here again, when we're going to write the query, when you see that the logic is split into two main things that are important, that looking at the revenue and then splitting those in a yearly basis or monthly basis, it's best to start with a CTE and then call in the main select statement, you call that first aspect that you wrote in your CTE. So that's something that I do usually. You don't have to, you can write a select statement that has everything, all the logic, but it gets a little bit clunky as well when you do that. So first we're going to start by looking at the annual revenue, and then we're going to look at the year-on-year percentage change, okay? So first we're going to do a with statement for the CTE, and we do annual revenue, and here we're going to have two columns. So first one, we're going to extract the year from order underscore approved at. We did the same with the month just before. So this one, extract the year from it, and we just call it as year, YR. And then we're going to sum the price. So we basically want to sum the price per year, and we just here round to 2 decimals. So we have 2 decimals after the dot. So if we have 20.45, so 2 decimals, it just looks cleaner, because sometimes it gives you some huge numbers. So we have, we're here joining the orders, and the orders because we get the date from it, and we're joining it to order items because that's from where we get the price. Very standard, we did this before, and we join on order ID, and here we again did where o.order approved is not null, but we could have, instead of using this clean order items or this one clean orders, we could have used the view that we created in here, KPI1 clean orders. So it's basically the same. You either add that one line or you use directly the one that is clean. I would advise to use the clean one, but it's just so that you understand that even if you miss it, you can still add it and so on. But it's good to keep track of what you're doing. So, and then we group by year. We want to see the results by year. So this is the CTE. Also, one of the advantages of a CTE is that it runs within your query. So this doesn't live anywhere apart from your query. It only runs when you run the query. It's not like it's somewhere, it's a variable waiting for you. No, it will run first when you run your query. So that's something to keep in mind, and it keeps things clean like this. And then we're going to look at year-on-year change percentage. So it's the current revenue minus the prior year divided by prior year, and you get the year-on-year percentage growth. So we're going to select year as year. So it's the one that we had in the CTE. We're going to bring the total revenue. So basically we bring the two columns that we created from our CTE. And here we're going to write this calculation in here. And it's basically what we see in here, the current minus prior divided by prior. So if we look at it in here, we see total revenue minus lag total revenue. This lag brings us the data from the previous year, from the previous cell. So we're going to basically do this current year minus the prior year divided by the prior year. That's what we do. And if the prior year is 0, we're just going to write null. That's why we've put here, null if. And then we just round in those results by 2 and multiplying by 100 so that we get the percentage in terms of percentage. So basically we did the current revenue minus, which is here, minus the prior revenue ordered by year, obviously, divided by the prior year in here. And if the prior year, because there was no data, is 0, we're going to put null. That's why we say null if total revenue of last year is 0. Okay, and we call it as year-on-year growth, and we take it from our CTE in here, and we order by year. I hope it makes sense. It's as simple as this. It's just that we added this one in case the previous year is 0, we just write null, and we multiply it by 100 to just get the percentage. And then if we run this, we're going to see 2016, 17, and 18. And obviously for 2016, we're going to have null because we don't have data for 2015. So there's nothing to compare it to. So that's why we have it here as null. One thing here that is important to notice is if we just look at the data like this, it just seems that we have this kind of growth between 2017 and 18 and a massive growth between 2017 and 16. We see 12,000%. But if you noticed earlier, when we looked at the monthly here, we could see that in 2016, we only started at September. And in 2018, we only stopped at September. So we don't have the full years. So it will be more fair to look at those exact periods. So for example, if I look between 2017 in September, or from January 2017 to January to September 2017, same for 2018, from January to September. And that will be more fair because we have all those months for both those years. Because this doesn't give you a real representation because we have so many missing months. And that's why the work of a data analyst goes beyond just writing code, is really trying to spot these kind of things. Because if you have a year that only had 3 months in it and you compare it to a full year, obviously you will have some results that don't make much sense. So 12,000% increase, that's ridiculous. So instead what we're going to do, we're going to look across 2017-18 between January and September. So basically the code that we did before is the same, it's just that we're going to add this condition in here. So we're going to again extract the year from the table, from the column approved at that we have in order, and then we're going to sum the price. It's the same as we did before. We're going to join order items with order on order ID, and here we're going to add this where clause here. That is important. So in this where clause, we again did that. We remove the null values from the date column, but here we're going to extract the month from order approved, and we're only going to keep between the first month and the 9th month, which is January to September. And here we extract the year and we only keep 2017 and 18. So basically we're going to compare 2017 from January to September and 2018 from January to September. And this is a fair comparison compared to what we did before. And then we do the year on year again percentage growth. But here we literally going to compare just these 2 years. It's the same code. We bring the year and total revenue from our CTE that we have in here. And then we're going to do the same calculation as we did before. We're going to look at the total revenue minus the previous year divided by the previous year. And put null if the previous year is 0, but in this case we know it's not. But this one is more of a, so that your code doesn't break, you just do it. That's a good thing to remember. And then we just round the results to get 2 decimals and multiply by 100 to get the percentage. So that now if we run this one, we're going to see that the year-on-year growth is 99% growth in 2018 compared to 2017. This is very interesting insight to get in e-commerce, and now you answered your question way better than before. So what did we have in here? We had 20%. So it didn't give us a good answer. But now we have it accurate because we only looked at the same month within the year. And you can say that explicitly. You can say between January and September in these 2 years. And this is the results that we get. And you can even explain why and stuff. And you can here, for example, you can add your own assumption. And then you can validate your assumption. You can say this search confirms that the platform is scaling rapidly even before the Q4, which is the quarter 4 of the year. It's October, November, December because we didn't include them. And usually that one is famous for Christmas shopping, end of the year shopping and things like this. We look now at KPI number 3. We have the average order value or AOV trend. Also an important metric that we look at in e-commerce. So we just want to know what is the average of the orders from people, basically. Well, how much is the average on a monthly basis, for example? And that's why we're going to look at the trend in here. So again, average order, monthly basis, two separate logics that we'll try to combine together. It's best to split them into a CTE and then call in the select statement. So you see then when you do most of the job in the CTE, the select statement is very clean because you just call what you did in here. So let's go over it here. So we're gonna do order totals. So we did basically like this before. We just bring our ID here. So we select these three columns, basically. In the select statement is the columns that we select in our table. So the ID, the price that we have in our order items. So we have the price in our order items. Always nice to go back, visualize the data because obviously it's important to understand the nuances, the connections and everything really well. And that's something that you do up front when you start a project because rushing into the code might seem cool, but then if you keep missing the most basic things where each column is and how to join them and all these things, you'll be just lost. So here now we have the price in the OI, which is the order items, and we're gonna get again the month from the orders table as well. So that's why here order o.order approved at as month. So we have the month, the sum of the revenue and the ID in here. So basically we're just getting the order totals per month in here. We join in the orders and order items on order ID as we did before. We're excluding the null values from the dates column, and we group the results by the month here and the order ID. So as I told you earlier, when you group by, you want to group the results, you always use all the columns that you have in your select statement apart from the aggregations. Aggregations, anything that is like sum, average, these kind of things. So here we exclude this one, but we keep the month and the order ID, and that's why we put them in here. Otherwise, the code will break and it won't work. Then we're gonna go here and we're gonna compute the average value order or AOV per month. So we're gonna do select, bring the month, and then we're gonna do average order revenue, which is the one that we did in here. We just want the average per month. So we bring the month and the average, and here we just give it a name as average order value. We round it to 2 decimals. That's a good tip to always do with numerical values. We don't want them to be ridiculously long for no reason. No one likes to read that. And then you do from order totals because we call it from the CTE, and that's all the heavy lifting you do it prior. And here you're just gonna group by month. You want to see the results by month, and you want to order the results by month as well. So if we do this, so if we do order by month, this assumes that this is ascending. So if you do descending, if you want to see them in a descending order, basically. If you want to see from the latest to the newest. But if you don't do anything, it basically assumes that it's ascending. So that's just something to know. That's why we have it from 2016 onward. So we look now at the average order per month, and we can see some sort of stability. Apart from here, maybe there were some missing orders. But overall, we have 130, 140, 150. So there is some sort of average that is respected in here. So we can say that AOV stays remarkably stable overall between 125 and 150. So the AOV doesn't change that much. Good to know. Shows a lot of stability. Now we move on to the second buckets. So when we spoke about the buckets, we said that we're gonna cover, I think it's the last one. Revenue growth, we finished with it now. We're gonna go to product category, then performance. So we can go a little bit faster now that we're used to the code and to the tables and everything. So this bucket, product and category performance, wanna more look at the products instead of the orders. So we're gonna use these tables, the order items, the product and the orders. So we have these products now that come into play. We're gonna look deeper into the products themselves and their performances. So KPI number 1 is top categories, the categories by revenues and units sold. So we can start with that. So this will answer the question, which categories actually drive the cash register and the volume? This is very important. So first of all, here it's a basic query that we're going to write in here. So we're going to bring the product category name from the table product P. So if we look, we haven't looked yet at the products. We have the product ID in here, and we have a few other things. And if you have a look, we can see the product category name, the name length, description length, whatever, not very interesting, the weight, etc. We'll need the product ID, the product name as well would be interesting to have. So we're looking at the category name from product P. So this is the shortcut to use. We're going to get the sum of the price that we got already from order items, so OI, and we're going to count everything. So we want to know, we want to count the units sold in here. Okay. So from order items we got from it the price, and we're going to join with products, because products we got from it the category name, product category name, and we're going to join them on product ID. So if we look in products, we have product ID, and if we look at other items, we also have product ID. So that's why we're using them both, and we are able to join them. We have an inner join here. We're going to group the results by category, the one that we created in here, and we're going to order the results by revenue. We want to see the biggest revenue, so we're going to order by revenue. And as we said, if we don't do anything, it will be ascending, so we will go from the smallest to the biggest. But since we're doing descending, DESE, it's going to show from the biggest to the lowest, and we're going to limit 10. It will show us just the top 10 rows, so we're going to get the top 10 highest ones. So if we just run this, we see that we have these 10 categories, product categories, with the highest total revenue and the units sold. So we can see, for example, this one, the Beleza Saúde, this is Brazilian, so it's Portuguese, has sold over, how much this is, 1.2 million with 9,000 units sold on this category. There's automotivo, so this is cars or something, bikes maybe, how many units sold, and so on. So now what we answered in here is the top categories by revenue and units sold. And we grouped by the category, and we got the order by total revenue. So we didn't look at the highest units sold, but we looked at the highest total revenue. So we can also add the description. We can say, okay, these are the categories that performed the most, and we can add some more insights to it as well. Looking at the KPI number 2 in our second bucket, we want to look at the fast growing categories. So we're going to look from January to September 2017 and compare them to January to September 2018. We did that before because we know we have missing months, so now we get to know the data and we are more strategic with it. So we're going to look at the fast growing categories. So spotlight categories with the strongest year-on-year growth, so the business can double down on the winners. So that's our aim in here. So let me zoom out. This code is a little bit more extensive, but don't be afraid of it because we're going to tackle it slowly. So again, here we have a CTE, but this time is a multi-CTE. So we have 2 in 1 basically. So you can just split them by a comma if you have more than one CTE. And then in the select statement, we're just going to call them in there. So let's start. Let me zoom back again a little bit. We're going to start first by looking at the revenue by category. And then we're going to pivot those into 2017 and 18 and compute the growth percentage. And then we're going to call them in our main select statement. So let's first start by getting the yearly revenue first. So we're going to create our CTE with period revenue. Okay, we're gonna call this, bring this 3 columns. So the first one is the product category from our products table, again, just to look at it again. So the product category name from the products table. So the products table here, we write it products P. So that's what we call it, P.product category name as category. We're going to extract the year from this column as we did already many times. So we are reusing some of the code. And again, we're going to sum the price from the order items table as we did again many times. So this is very basic. Now we're going to join those 3 tables. So now we got the product category from the products table. We got the date from orders, and we got the price from the order items. So we have 3 tables, they need to be joined, obviously. So first we join the orders O and order items, they have in common the order ID, something always worth double checking. So the orders items here, order ID and order ID in orders as well. And then order items also has the product ID that we can join in with the product table that also has product ID. So that's why first we do orders with order ID, with order items on order ID, and then again another inner join on products using the product ID. Okay, so now we joined one and then joined it with the other one, so we joined the three of them basically. Here we're adding a condition as we did before. We just want to not include the null values in the date that we have, and we want to extract just January to September and 2017 and 2018 for comparison. We're going to group by the category and the year, and we're not grouping by the aggregation column. So that's our first CTE. Then we do a comma and we jump into the second part of the CTE. We don't have to rewrite the width. We're still inside of CTE. It's a multi-CTE. So now we're going to pivot this. So we do cat growth. So we're going to look at category growth. We bring in the category as we just did in here. No need to rewrite it. We can reuse it. And here we just want to look into the revenue of 2017 and the revenue of 2018. And here we're using the case when to pivot the tables, and we're using the max to get the max value of each and every year. And then when we're going to compute the result in our main select statement, we're just directly going to call the category. We're going to call the revenue for 2017, the revenue for 2018, and then we're going to calculate the year-on-year percentage growth as we did before. So it will be the current revenue from this year minus the previous year divided by the previous year. So it's the same exact one that we wrote before. We multiply by 100 to get percentage. We round it to 2 so that we get the 2 decimals, and we do the null if, so that if the previous year is null, it won't throw us an error. It will just replace it by null. And we call it here year-on-year growth from cat growth, which is got it from here. And then we just add in here a condition. We want the revenue from 2017 to not be null, and also the revenue for 2018 to not be null. Otherwise, you won't be able to calculate the year-on-year growth. We order the results by the biggest year-on-year growth. We can see descending and limit by 10. So if we run this was a little bit of a complex one, but as you can see here, we can see the biggest year-on-year growth in the descending order. So we can see that these categories have been the ones with the massive year-on-year growth overall. So we can report on this and say, hey, these are the ones that had the best results on year-on-year, which are massive growth. And here, obviously, you can add again a description so that you just report on what you just did before. Okay, next KPI 3, we're gonna look at the high average order value compared to low volume categories. So here we're gonna identify premium niches, items that sell fewer units but deliver outsized revenue. So this one is interesting, so we can see the pricing power. Some categories, they sell really well in terms of the prices, even without necessarily selling too many items of it. So here we're looking at the average order value is the total revenue divided by the number of orders. So here, let's keep going in here. So we're gonna again have a multi-CTE. Here, the first one, we're gonna compute the revenue and units per category. We're gonna then derive the average price per item. And then we're gonna filter those categories to get the below median units, but above median average price. So this one is a little bit interesting to look into, but let's do it step by step. So first, we're gonna create our first part of the CTE with category statistics. We're gonna bring the product category name as category from the table products. We're gonna do sum of the price as total revenue, and we're gonna count everything as units sold. So we want to know also the units sold as well. So we get order items is where you get the price from, and the product is where we get the category from. And so we join on the product ID. It's the common column between them. We group the results by category. So now we got basically the revenue and also the units sold per category. We're gonna derive the average price per item. So we're gonna do in the with clause, we're just gonna do a comma and then we're gonna start our second part. I made sure to add comments here so it's clearer. So we do the category average order value. We're gonna select category. We're gonna select total revenue and units sold. So basically we're bringing everything that we got in there, but the only thing we're bringing in here is this calculation in here. So we do total revenue multiplied by 1 divided by units sold. And here we do round to. So here we just basically doing the total revenue divided by units sold, which is the AOV, basically how we calculate it in the first place. And here we just call it as average price per item, and from category stats, which is from the first part of our CTE. So basically here we just created the AOV, which is the average order value, and we just use these all to do it. Now in our main select statement, we just filter in the categories below median units, but above median average price. So what we're gonna do here, we're gonna select everything from cat AOV, because now it's the one that has everything that we need. And here we're gonna put some conditions here. We wanna look at the units sold to be below the 50% percentile. So a percentile is like a split in terms of if you have a spectrum of all your data. If you say percentile 0.5, you're like 50%. If you say 0.75, you're 75%. So you want to look, for example, in here below 50% in terms of units sold. So we want the lower amount of the units sold, basically, within the group units sold. So we're looking basically at the units sold in here from cat AOV. So basically from our CTE in here. And we want the average price to be above the 50% percentile. So at the same time, we're looking at, we're filtering by the categories that have a low amount of units sold, like on the 50% lower percentile. That's why we have below 50%. And at the same time, the second condition is we want to have the price to be higher than the 50% percentile of the average prices overall, within the average price item that we also have in our cat AOV, which is the one here. Then we're going to group the results by the biggest average price in a descending order to just get the top ones, and we limit by 10 to get the top 10. So the results that we're going to get in here is the ones with an average price and a low amount of units sold are these ones. The PCs, this Casa Forno Cafe, Elettrodomestico, and all these things are the ones that have the highest average price per item, even without selling necessarily thousands and thousands of units. So this one is a very interesting one to work on. And you see here the logic is that the more we have to split how we calculate or we query the data. For example, here we had the basically the revenue first, then we calculated AOV, and then we just did a filtering so that we can get the lowest unit count compared with the average, the highest average count, and to make it nicer and more readable, we had to split them like this. You don't have to necessarily, but it just looks better and more readable in my opinion. Yes, this is a longer query, but usually you start slowly and you just build up your way into it. So again, a description for it is that, for example, PCs average 1,000 per item on just 200 units, delivering and so on. You know, you just elaborate on what you did. Now we jump into the last bucket, and this one is just geographic insights. This one is quite straightforward. We just want to know more about if there is any insights that we can get from performance per state, per city, compared to the national level. And in here, we're going to use order items, customers this time, so we can get the customer state or the city as well, for example, and the geolocation. So we have a table here. So if we look at the customers, we can look at the customer zip code, the city as well, and we do have the geolocation in here that also has the zip code as well and the city. So we can look into them now. So first one, we look at the revenue by city, the top 10. So again, revenue split by city. We're going to do the revenue in the CTE clause, and the city will be in our main select clause. So we're going to just do order totals. We're going to take our order ID from the orders table, geolocation city from the geolocation table. We're going to sum the price from order revenue, from order underscore items. So we have the ID from orders, we have the city from geolocation table, and we have the price from order items. We're gonna first join the orders with order items as we did before on order ID. Then we're gonna join order items to customers on customer ID, and then we're gonna join customers to geolocation on the zip code, because you would think, why don't we skip customers here? Because we haven't used customers in the select statement. But the only way for us to link order items to geolocation, so if we look at geolocation here, we can see the zip code. But if we look at order items, we don't have the zip code. So there's no way we can link them together. But if I look at the customers, we have the customer ID in here, which we can link to orders. So that's why we did here. So we linked it to orders. And from there again, we linked the customers to geolocation using the zip code. Because if we look at the customers, it has the zip code. And if we look at the geolocation, it has the zip code. So it's just a way to always find that common link and column so that you're able to join. And in this case, we had to go from orders to order items, and from orders to customers, and then from customers to geolocation to get all the information that we need. Then we just group by order ID and city. So we basically group by all the columns apart from the aggregated ones, which gives us just these two. That's what we did in here. And then we're going to aggregate per city. We basically call city that we get in here. We get the order revenue, which is in here. We just want to round it to 2 to get it to look nicer. And then we just call it as total revenue from order totals, our CTE. We group by the city, we order by total revenue from biggest to smallest, and we limit to 10. So we're going to get the top 10 total revenue per city. We can see Rio de Janeiro first, Sao Paulo second, and so on, which is not much of a surprise, to be honest. Next here we have KPI 2, average delivery days by city. So we want to look at the top 10 slowest average delivery days by city, and it will help us identify the regions with slow shipping so operations can review carrier or warehouse strategy. So this one is, we just want to figure out which cities usually have an average delivery that is very high, and we don't want that, so that we can understand what we can do about it. So this is more of an optimization problem in here. So we have this select clause in here. So we're looking at the city from the geolocation as we did before. And here we're going to look into the average delivery. So here what we're going to do, we're going to look into the order approved at and the order delivered at. So we have, if we look at the orders, we had a few different date time columns. So we have the order approved at, and we have the order delivered carrier dates. This one. So customer date, customer date. So we're gonna do the difference between them. So we're gonna compare the delivery date to the approval date, and that will give us the difference. And then we're gonna just average it. So first we're gonna do date difference between the arrival and when it was sent in days. So that's what we do here in days. And we're gonna get the average of them. We wanna get the average. Then we just round by 2. So that's why we get all this beautiful here calculation in here as average delivery days from orders. We're gonna join it to customers onto customer ID, and then customers, we're gonna join it to geolocation on the zip code. Here we have where order delivered customer date is not nil, because we want to avoid the ones that are nil. We could have done the same to the other one as well. We group the results by city and order by average delivery. We want to see the highest, and we just limit by 10. So basically here we look at the cities, we will look at the ones that have an average difference between the delivery date and delivery of approval that is the highest, basically. And we're going to show the top 10 in here. We can see the average delivery days, 148 days, 108. This is quite high, and this is not good. And they need to figure out what is it. Is it logistics? Is it transportation? Is it whatever issues? This is something that is discussed internally, usually within the teams. But this is a very good insight to get just within a few simple lines of code. If we look at the last KPI, KPI 3, we have the order versus the revenue share by city. And this one is to spot high order count but low revenue. So a lot of orders but not much of a revenue, and that's either we're gonna adjust the pricing or mix it with other products or something. So this is more of a, again, an optimization thing to improve the pricing and things like this, which is very important in e-commerce. So here we're gonna have again a multi CTI, and this one in here we're gonna have the order count and revenue per city. We're gonna get it on a national level, and then we're gonna look at the share percentages per city. So let's start first of all in here. So we look at the city stats, and we did this one before. So we just look at the city in the geolocation table. We get the distinct order ID. We want to get the count of distinct order ID. We checked initially and we saw that we didn't have any duplicated order IDs, but in some cases, if this is the only query that you're working on, you'd rather do it as orders. And here we want to get the revenue, sum of the price from the table order items. So we're going to again join orders and order items on order ID. And again, in order for us to get the geolocation, we have to go through the customers because we can only link the customers to the geolocation via the zip code. So we do order to order items, then order items to customers via customer ID, then customers to geolocation with the zip code. We group the results by city. Then we're looking on a national level, totals. So what we're going to do here is going to look at totals, and we're going to select sum of orders, all the orders, and sum of revenue, all the revenue. And this is on a national level. We're not looking at the city here anymore. This is looking at the overall, the whole country of Brazil from city stats, because we got everything from this city. And now if we go to our main clause, what we're going to do in here, we're going to call the city, okay, because we want to see the share percentages per city, and compare it to the national level. So how much each city has as a share of orders and revenue within the whole country. So here what we're doing here, we're just basically doing orders divided by national orders. So let's say Rio de Janeiro compared to the whole Brazil, or Brasilia compared to the whole Brazil, or Sao Paulo compared to, we want to know each and every one and see the order share percentage and the revenue share percentage. So that's the same logic in here. We multiply by 100 to get the percentage, and we round it to 2 to get the 2 decimals. I feel like I said this one quite a lot. It's just a standard way to write things. From city stats, so city stats is here, and we cross join with total T. So cross join is basically it does create a Cartesian product, and every row in the first table gets combined with every row in the second table. So this one is interesting, and that's why I added a little bit here of a context in here. Since totals is a signal row CTE, or single row CTE, it only contains national orders and national revenue as one single row. And by doing a cross join, it will end up getting as the results for each and every one of the cities. So here we use cross join to add the national orders and national revenue columns to every row from city stats, not just to one of them. So what it does, basically, it merges each row from city stats with the single results from totals. And therefore, we're gonna get here the revenue share percentage per city. So for example, if we look at Rio de Janeiro, the revenue share of Rio is the highest with 13.3% of the whole national revenue is in Rio de Janeiro, and the order share percentage is 4.5%. So less orders, more revenue. Rio de Janeiro is definitely doing the best. And then you can see all the others and so on. We have the top 10 in a descending order. So here I just added some extra context on cross joins, because I know a lot of people don't use them much. I don't use them much neither. So here it's safe when one of the tables has exactly one row, like in our case here, the totals. You intend to apply a global value to each row based on that total. So that total will just go into each and every one of those rows, and that's how we call a cross join. Basically here, a project summary. Just as a reminder, you have everything on the GitHub that I will link in here. I showed you how to set up everything. This is from where you get the data set. I have here just a link to my LinkedIn where I just shared the basics of querying. You can see the select, from, and all these things. You can even connect with me, always welcome. And again, I can also share with you guys this PDF in here that I've created for this video. I can put it also on GitHub so you can have access to everything. I hope you enjoyed. This is one video of the series that I'll be making on full end-to-end data analytics. Today we massively focus on SQL in DuckDB, and in the upcoming videos we can focus more on Python, on things that we can visualize more, things that can be also very flexible. SQL is one of those best ones that you need to have and to learn in order to be a great data analyst. So I hope you enjoyed this one. If you have any recommendations, please just leave them in the comment section. I'm also launching a 4-week cohort soon, so I'm still working on it, and I will be covering things like this and even deeper. So if you're interested, I will leave a link in the description below where you can sign up in right now. You can just sign up for free, and you will get a 75% off when the day will come. I'll just send you an email, say, hey, if you're still interested, you have 75% off, and you can join the 4-week cohort that will show you everything that I do as a data analyst. We won't be working with the very basic data that you can do in 15 minutes. We will work on real stuff. And for now, if you want to dig a little bit more into a football analytic projects that I did before, I will just link it for you here. That you can go have a watch. I have plenty of other videos that I go through Git, NumPy, Python. So just go and explore them. If you enjoyed this, please remember to subscribe to the channel. It does help me massively. You can comment as well if you have any ideas, any things you struggle with, and I will try to help you with it. Thank you for watching.